Hello there. Welcome to another exciting day of discrete mathematics. Today we're starting our topic on graph theory and Euler networks. We saw a little bit where we're trying to trace a graph and find a way around, but here we're going to introduce a few definitions that we need for graph theory and go from there. Now, first off, graph theory, we've got the study of networks and connections that can be made between points and the lines that connect those points. Here on the right side, I have an example of something called a graph. We have all of these points. We're going to call those vertices. And we're going to have the edges, lines that connect them, showing a way of going from A to D, D to B, and so on. So a vertex is going to be any point on a graph. So for an example, A is a vertex. An edge is a word that we're going to use for a line connecting one vertex with another, and that's going to be represented by two letters. So example, DB. Now DB could be the edge, the straight line edge I'm highlighting here, or it might be the edge that I'm using kind of my dashed line on top, the curved line. Either way, those are two different edges there. But an edge is any line connecting one vertex with another. Our graph is this collection of vertices and the edges that connect them. Now, a special type of edge is called a loop. And we look over at E. We can go from E all the way back to E. It doesn't touch any other point along the way. That's known as a loop. It's an edge that connects a vertex to itself. And we would denote that with a pair of letters, in this case, EE. So we're starting at E and we're ending at E. Now specifically, we're going to be looking at things called paths and circuits. A path, for us, is going to be a trip around the graph that begins and ends at a different vertex. One such example, we could start at A, I could go to D, I could go to B, and I can go to C. That represents a path. And I would indicate this by the order of the vertices. I'm going from A to D to B to C. That's just a simple path. It's one way going through a set of vertices. Now we're looking at specifically Euler paths. And Leonhard Euler, Swiss mathematician, was concerned about crossing every single edge exactly once. Later on, we're going to see something where we don't care about crossing each edge exactly once, but crossing each vertex exactly once. Now in here, a sample Euler path might start at A, go to D, go to B, go back to D, go to E, go around the loop, up to C, to B, and back to E. And I might denote that, going A to D, to B, to D, to E, back to E, to C, to B, and E. So notice we started at one vertex and we ended at a different vertex. We started at A and ended at A. That is an example of an Euler path because we started at one vertex, ended at a different vertex, and we crossed every single edge exactly once. I'll leave it to you to try the remaining few examples. Can you find an Euler path for each of the following? Note what's special about where you start and where you end. It may take a few tries, so try it out, see where you go. The other topic that we look at in Euler networks is a circuit. So a circuit, different from a path, is that a circuit is a trip around the graph that begins and ends at the same vertex. So on my graph here, a sample circuit, I might start at A, go to D, go to C, and then back to A. And I would represent that A, D, C, A. Notice that I've looped back to the beginning. So a circuit is closed. It's going to go back to the start. Delete that for now. Now, every circuit is a special type of path, but for our purposes, we're going to distinctly separate a path and a circuit. A path is going to start at one vertex, end at another, and a circuit is going to begin and end at a single vertex. Now, Euler, an Euler circuit, crosses every single edge exactly once. Same idea, but a circuit, especially, returns back to the beginning. So if I highlight this, if I start at A, I could go to D, I could go to C, to B, to E, to C. Notice that I'm allowed to hit C more than once, and then back to A. I've crossed every single edge exactly once. I've gone A, to D, to C, to B, to E, to C, to A. And that loops back to the beginning. So that's an Euler circuit. We've crossed every single edge exactly once, and we've returned back to the beginning. Leave it to you to try out those examples. The mild might be a little bit easy, on up to the spicy. Each of these does have an Euler circuit. It might take a few tries to get your way through them, but remember, every edge exactly once and return back to the beginning. Where do you have to start? Where can you start? That's it for now. See you later.